So hello team, I hope you are well, fine and good. So welcome to this another video session. So in this video analysis we will be discussing about a very interesting topic about AI and how this AI leads to an attacker compromise. Okay, so it's all about use AI. So then use the AI and help the attacker to attack your system. So that's how we in this video will be going to discuss about regarding the friendly fire. So what this friendly fire is all about and how what are the big idea behind this, and we'll be going through each and everything, the initial phase to the ending phase. So we'll be discussing each and everything in detail, so please stay tuned and subscribe this channel to get the latest update regarding any cybersecurity efforts. So fire friendly, so what this fire friendly is all about: when an AI coding agent, when an AI coding agent executes the attacker's code. Okay, so what does this coding agent does the attacker's code? Okay, instead of finding vulnerabilities, it runs this code. Okay, it's a loop, right? So ask an AI, coding agent. Okay, so just a command I can start giving you, like ask an AI agent, to scan open source code for security loopholes or holes, and it might run the attacker's code on your own machine. So that's the finding. That's the finding in a proof of concept by AI now institute called friendly fire. Okay, the concept called proof of concept comes into role or comes into place. So when we discuss about what actually happened over here, so that might be the interesting point which we need to discuss. So here AI agent ask, again I repeat, AI agent is asked to review untrusted open source code. Okay, so then instead of analyzing the open source code, so they started executing a malicious script, on the user's machine. Okay, so then the attacker gained code execution with the user privilege. Okay, so this is what actually happened. So tool effects, what are the different tool which usually comes into effect? That is all about Anthropic Claude code. Okay, version 2.1.116, 197, 198 and 199. Okay, so the model Sonnet 4.645 and Corpus 4.8. Okay, the OpenAI Codex and model GPT 5.5. So autonomous model. So what are the different autonomous model comes into role? So the Claude code auto mode, Codex auto review. Okay, so these modes use a classifier to run the command in the agent. Okay, just saves and also pursuing only on the one that is flagged as risky. Okay, the attacker requires on off this device to be on. Okay, so this is how the autonomous mode actually comes into play or role. So then after important caveat, so there is no specific vulnerable version range. The weakness in this design is the workflow, not a particular build. Okay, fix is a change in workflow, not just a version update. Okay, so this the important takeaway which we need to understand. So then we will be discussing about how the attack actually works. I can say the step-by-step process of this. One is attacker prepares respiratory. Okay, so the first step is all about preparing a respiratory. Okay, so then the attacker adds a seamless helpful note of readme suggesting the run security .h before opening PR. Okay, so this is the readme file which have been illustrated or displayed over here. Then the malicious payload is hidden. So in that security.sh, malicious payload is been inbuilt or hidden, right? So this script quietly launches a hidden binary that carries the real payloads. Okay, so then the binary and disguised. Okay, so then the binary been disguised to safe.go to safe. Okay, so binary made to look like a compiled build of harmless go file, sitting right beside it. Okay, so then it's seeded with the string from that go file, so disassembly check appears consistent. So followed by user ask agent. to test the security. So perform security test on the projects, okay, where the user gives a normal instruction to the agent, followed by agent read the readme file, okay, agent interrupts the instruction as part of the requested task like readme run, then before OPR. So auto, approval says safe, okay, agent decides the command is low risk and run it without any sort of asking the user, then the payload execute on the host. Okay, the attacker binary executes on the user machine, so no harm, no approval box code run. So this is how the process or the attack flow is being, in the AI agents, okay, which you have been working with. Folks, please stay tuned about the mitigation and what safety protocols we need to, take into consideration. So why safety check failed? So why here the safety called AI safety failed dramatically? So safe command like, classifier, so command look like routine security step where the binary inspection dissembles, okay, so where the binary, resemble legit built artifact from nearby go source, respiratory consistency, malicious binary, not referenced in code, so nothing looked out of, space. So user confirmation prompt, no prompt because automatic approval mode was enabled. So what is required over here? Okay, so we need to understand the command executes, AI agent, okay, CLI and D with cell access followed by autonomous self approval, mode enabled, reviewing the untrusted third party code, where, respiratory content instruction that, pre-dual agent to run a command, followed by the potential impact. Okay, so what is the potential impact of this? Then arbitrary code execution in user privileges, okay, read modify files, then access credential and SSH keys, cloud token, then network access from the host subject to local policies, further compromise of the dev environment and CI/CD. So these are the potential impact of this. Okay, what is not required? No software exploit in Cloud Code or, Codex. Okay, no need for user to manually type any sort of malicious command. Project code does not need to involve the payload, so does not, depends on one specific library. GeoPy was just a demo, target. So coming to the practical mitigation, most important first. So one is we need to disable the autonomous or self-approved mode of untrusted respiratory. Requires a prompt before, every cell command, followed by a review command, before execution. So then treat readme instruction as, as untrusted content, then use, isolation, okay, run agent is disposal VM container core or remote sandbox with, minimal privileges. Use a separate low privilege account for code review tasks, followed by avoid exposure personal SSH and cloud credential, followed by block the output network, network access where possible during the initial inspection known for projects. Specific, strategic or specific static analysis first, analyze code and, explain finding before running any script test or build. Clean up after review, destroy the sandbox container and rotate the credential if exposure is suspected. So safe operating procedure, one is clone the respiratory into a temporary contaminant or VM, start the agent with manual approval for every command, ask analyze the code only, do not execute any command, okay, at like any script built on readme instruction that, that would require execution. Personally review the proposed command, execute only minimal or very limited necessary commands inside the isolated environment. Okay, destroy the environment when it actually finishes. This is how the important safety precautionary action we need to take, and these were the most mitigation steps we need to follow. So key takeaway is all about the fire friendly is a supply chain social engineering attack, okay, against any autonomous code agent. Okay, if AI agent can run command on a machine that approve its own action, a malicious respiratory can invoice, okay, attacker control code during a security review. So this is how the safety precaution we need to take regarding the friendly fire. I hope you have an interesting topic which I have displayed over here. So if you like, please do a subscription and save the channel as soon as possible, folks.